All right, so let's kick it off. Again, thank you for showing up to the session. I hope you're all pumped after the energetic keynote for the last 3 hours. So today we're going to talk about an event-driven real-time supply chain ecosystem that was built by Australian Rail Track Corporation, powered by Lakehouse, right? So before we jump onto that, let's quickly introduce yourselves. So I'm Deepak. I'm a senior solution architect at Databricks, based in Australia, in Brisbane. I've been with Databricks for 3 years now, and I have like about 12 plus years of experience helping customers build data and AI solutions across Asia Pacific. And today with me we have Harsh Mishra, who is the lead enterprise architect at Australian Rail Track Corporation. He helped ARTC shape up their digital and data strategy, and is also helping them deliver it now over the last 3 years. And he's also one of the co-founders of S4G Consulting, and he's also the CTO there. And he and his team provide architecture as a service advisory to customers across in Australia. So with that, I will hand over to Harsh, who will kick it off with an intro about ARTC, and then he'll walk us through as to the journey that they took, and then I'll come in the end and talk about the technical side of things. Over to you, Harsh.
Thank you. Can everyone hear me? Excellent. Yeah. Good day, everyone. I'm still very pumped from the keynote. Geez, how many amount of people are there? We are from Australia, and we don't even have that much population. So it's a bit of a bit of a shock for us. So yeah, please bear with us on that as well. Second thing is, yes, as Deepak mentioned, I'm in the business for 20 years. From my dress up, you can guess I worked in the US on the Eastern Seaboard. Definitely not suitable for Silicon Valley. So I moved to Australia for the last 13 years. Today, we are going to talk about Australian Rail Track Corporation, which is our national railways. Before, let me just show you a short video first, and then I will sort of summarize who we are and what we do.
For more than 20 years, the Australian Rail Track Corporation has been a vital link in Australia's transport supply chain, a national network that moves freight and passengers. We're part of a very successful team, employing more than 1,800 people across 39 sites, the majority of which are based in regional locations. Together, we look after more than 8,500 kilometres of track, spanning 5 states. And over the past 15 years, we've invested more than $7 billion developing a reliable and efficient network. Our people manage the safe transit of 450 trains every day and transport more than $14 billion worth of goods every year, the equivalent of more than 2 million B-double trucks worth of freight. And we're not stopping. Why would we? Rail is the future. Cost and energy efficient, reliable and safe. As Australia grows, so do we. With our focus on the future, our purpose is clear: to improve Australia's productivity by making rail the mode of choice in the national supply chain. Our teams are busy building, upgrading and adding the missing links to connect Australia north, south, east and west, including the Inland Rail project. This new rail infrastructure will deliver a fully integrated national network and boost the country's freight capacity. We're creating much more than new railways. We're opening up a world of opportunity for businesses and regional communities. We know we have distinct competitive advantages to keep Australia moving. On rail. The future of rail in Australia is bright. The opportunities are enormous. Together, we're on the right track.
Perfect. So as you have seen, the total amount of cities you have seen in Australia, you have got it here about in 200 miles radius. So the problems we have got is very different there. And also, the distance that our rail network covers there is also very different. But by the video, you have now noticed that we play a very important role in the Australian logistics supply chain and majorly provide 3 key business services or business capabilities. We do network planning. We perform the rail network operations. So all the network operations are done by us. And we also provide rail network maintenance. And most of the session today, I'm going to keep going through these 3 business capabilities and how we have transformed these 3 business capabilities using data and Databricks. So that's the point of today's session.
Hey, Harsh. I thought I'd probably throw in a quick question before we move on.
Yeah.
Just a quick icebreaker. Like, anybody wants to take a guess, when was the first rail was ever operated in Australia? The first train that ran in Australia, what year was that? Just take a guess. Sorry, what was that? 1830. Yeah, wish Australia existed at that time. 1875, great guess. Another one? 1850, that's close. This person got it super close. 1854. I was the first year when a train actually ran in Australia. And ARTC has been founded in 1997 after Commonwealth, and they've been operating since then. And they manage like about 8,500 kilometers worth of rail infrastructure across Australia, and they are the heart of supply chain for Australia. So I thought I'd probably.
No, that's a good point. It's always make sure that audience are still not asleep, so that's perfect. All right, so what we did, so in 2020, that's where I sort of joined ARTC, and my major role was to enable their digital strategy. Because of that vision that you have seen, that we wanted to make rail as the mode of choice for Australian logistic chain, we said, okay, how are we going to do that? So we started focusing on 3 key pillars of our digital strategy. We said, okay, let's use data and AI power to understand our customers better. Now, basically for ARTC, everyone out there is our customer because every company that operates rail is our customer. I'm sure you must be knowing this, that Australia is a mining country. We produce lots, we dig lots of stuff from the ground. So all those miners are our customers. All the big grocery stores are our customers. So the idea is we need to understand how our customer thinks, what are the services they get from us, and how we can provide the services better to them. So that was our first thing. Second most important challenge, or the theme that we wanted to transform was network optimization. So ARTC main revenue is based on the tonnage. What that means, the more tons goes through the rail track, the more money Australian rail track will make. So we wanted to make sure that the trains never stop, but at the same time, the maintenance keeps going of the tracks. So we wanted to use a whole bunch of, again, data capability, digital capability to optimize our network and run as much trains as possible on that. And third is we wanted to make our maintenance more and more predictive in today's day and age. So that was the first pillar. Second is the most important part for us is safety. I mean, I was very fascinated because as an architect, I love to go on the field, and I work a lot on the track as well with the field workers. And a 1.5 kilometer train, if it is coming behind you, you won't even realize it until it is 50 meters apart. And normally, the thumb rule goes is it takes a train to stop equal to its size. So the distance it takes to stop is equal to its size. So if a 1.5 kilometer long train needs to stop, they need to push brake 1.5 kilometers before. But the way these beasts run, you can't even hear them just 50 meters. So when our track workers work on the track and various people crosses the track and everything else, we wanted to make sure that they are safe. So safety is very important, and I will show you some examples of how we have used data to ensure the safety of our network. And third is we wanted to, again, as probably with every other business, we wanted to automate our end-to-end business processes, especially focusing on those 3 capabilities: network planning, network operations, and network maintenance. So that's sort of the strategy path we have taken. Now, what was the challenge? It sounds awesome, right? But what is the biggest roadblock we have got to address in ensuring how we address this strategy. So our challenge was to, again, transform those 3 capabilities that I've highlighted, which are mainly supported by these 4 key pillars. So as I said, safety. Whole bunch of operations happens on the track, whole bunch of operations happens on the train. We wanted to make sure that we definitely go towards the zero harm, and we will show you some graphs later to prove that how we have achieved that. Second is, we wanted to make our network efficient, and we wanted to make sure that the network, we can run, as I said, as much trains as possible, but at the same time, it needs lots and lots of maintenance. So we wanted to make sure that the tracks are safe so that no accidents or anything will happen. And we want to also ensure that all the people and productivity are working most efficiently across all these 3 pillars. So the biggest challenge was to establish the right balance between these 4 things. It looks simple, but it's very difficult to achieve, because always in a bigger business like ARTC, you will talk to the maintenance crew or the maintenance manager or the maintenance head. For them, the maintenance of the track is the most important thing. The maintenance of the signals is most important thing. Then you talk to the network efficiency people or network controllers. For them, running trains is the most important thing. So ensuring that all these most important things of all these most important people comes together, but at the same time, to calibrate all this expectation is the biggest challenge for us. And making sure that we spend just optimized time in all these 3 operations or 4 operations is where the biggest challenge was. As you know, how we can do that. So the way we can do that is by integrating all the systems that are enabling these pillars or these capabilities. And the way we did it is by created an end-to-end data layer with most modern event-driven architecture available in the transport industry in Australia. So that's what we are going to talk to you about today. So ARTC is an event-driven business. We run on the events. When the train starts, we do certain things. When the train reaches the journey, we do certain things. When the train crosses a weighbridge, we do certain things. We need to make sure that we respond to those events digitally and make these capabilities perfect. So that's how we did with integration and data layers. Now, but as happens with every business, we were not as polished as I'm looking today in 2020. So in 2020, we were like any other organization where you can see SQL. We have got a good amount of SQL staff. They pray SQL every day. And the major problem with that is we also had lots of disparate data systems in 2020, where all those systems are ingesting the data into the SQL, but those ingestions also was happening through SSIS, SSRS. We have done a whole bunch of customization on the reporting side, and at the same time, we have also have got lots of direct database accesses, which always created the problems with the performance of those systems, as usual. So that's where we said, okay, now that we know where we are going, now that this is the strategy we need to achieve, how we go about it. And that's where I got introduced to ARTC and my business got introduced to ARTC. And the first thing we did is we created a business blueprint. We said, we sort of took a step back. We said, to address these problems, we need to understand our why, what, and how very well. And for that, we created two major things. a business blueprint and a technical blueprint, or business reference model or a technical reference model, or business capability model or a technical capability model. You can call it anything. But the gist is, it is that central place where we can see that, okay, this is how our business looks like. These are the capabilities our business provide, and these are the capabilities we wanted to transform, and then we create a technical capability model to enable it. Like, it's the same thing, like how many times when you work for a business and someone asks you what your business do, 90% of people can't define their business in 3 sentences. At least we can now do that by having a very clear business capability model. Now, we have created it to the 3 levels. So we have, it's a pretty big chart, a big A1 poster, which is there in every executive office in ARTC now. It shows how many business capabilities we have got at the channel layer, which is why our business is needed, at the core capability layer, which is what is giving real dollar value to our business, and at the enable capability layer, which is what are the capabilities that are enabling it, so that we can very clearly able to understand, okay, these are the capabilities we want to transform first. Then we enabled a technical capability model, so which is like our key reference architecture for everything going forward. So this became our anchor point. We have gone with a decoupled architecture where you can see we have sort of abstracted the data from our system of records, removed all the idea was to remove all those direct access SQLs and everything else, and create a good data storage, processing, and orchestration layer at the center, and capabilities to enable them, and eventually sort of create a good event directory. So this is what I've seen a lot of businesses won't go because won't probably achieve or do is they focus too much on the data, but I also wanted to emphasize today that we should also focus on the integration layer. What we have managed to do by our integration layer, we have now got a good enterprise event directory. That means any event that occurs in our enterprise, we have got the storage of it. What that means is we can trigger the actions, the processes, the various data aggregation jobs today, but we can also do it tomorrow on the same events without, again, capturing the events. It also helps us to manage the safety or do the safety audits. So let's say in the event of an accident, we can always go back to now our data, our lake, our event layer, and understand what sort of events occurred to sort of then, which then concluded to an accident or something like that. So it has given us that tremendous power. And then we have created our process automation layer or end-to-end automation layer on top of it. So that, yeah, sorry. Yeah, no, okay. Yeah. Yes, and definitely I'll open the question answers later, and I'll explain you. And yeah, please talk to me after this as well. And that's a pretty cool thing to do, actually. And that's how we have then created a bit of a fit-for-purpose composable applications on our presentation layer. Again, this has given us that tremendous power that we have got. Now our business. This is our business capabilities. These are our technical capabilities. This is how they should be architected. And that means now all our future architecture design, technical decisions, technical investments are governed by that. Then we said, OK, let's take a bit of an MVP approach. But it is I would mainly sort of call it as MVSP. So then we said, OK, now that we have got the blueprint, we have got the reference architectures, executives started getting a bit of a feel that, yeah, there is something big going on here. But they wanted proof now. They wanted to see the value. They wanted to see the rubber hitting the road. And that's where we have taken, how we can use our first patient to build the hospital. So now that because we have got this end-to-end layered architecture, we can see what we need to do in the infrastructure layer, which is cloud. We can see what we need to do in the data layer, integration layer, and automation layer. We figured out a most valuable and sensible business case, or most valuable and sensible use case. We started building that. But while we build that, we made sure that we build our enterprise cloud platform to the enterprise grade. We made sure that we build our data platform to the enterprise grade, integration platform to the enterprise grade, but end-to-end in a thin sliver of that reference architecture to show and prove the platform and show the value to the executives. Now, how that use case looks like. So that's where it's time to leave the train, and there are some awesome animations done by Deepak there. So we said, OK, what can be that use case looks like? Most valuable and sensible use case. So that was that, the yellow truck. No. The use case was we had 5 web bridges across the network with aim of delivering reliable weight data to coal producers and rail haulage providers. We also wanted to auto-calibrate those web bridges. And that's where we said this is our best example, because they were the most legacy systems. Literally, the system that takes the data out of web bridge is a desktop. So we said, if we manage to transform this, if we manage to take the weights from these web bridges in the real time, when train crosses them, able to expose the data, aggregate the data with various other systems of scheduling and maintenance, and able to expose it to our coal producers and our customers and create that API economy, that can be the best way to prove the value and the best way to prove the platform that we have created a composable architecture. It has helped us to solve the billing errors, which goes into millions. So there was right there some monetary value. It has helped us to improve the data quality. And it has most importantly helped us to reduce the calibration cost of those web bridges. Because to just calibrate those web bridges in a year, it cost us about $10 million. We have reduced it significantly to about 100K to 200K. So there are lots of value we have generated for ARTC just by one use case going through that. Now, what we did in that use case, I'd love to hand over it to Deepak, who is way more technical than me, to explain that.
Thanks, Harsh. I hope you're able to hear me OK. Awesome. So yeah, web bridge capture was the MVP that was actually selected to prove out the value of Lakehouse. And we heard from Harsh as to why this use case was chosen, because it was too legacy. But ARTC also had another reason to actually choose this as a use case, because this use case is all about time to realize revenue, right? So if you can see the left side and the right side of the image, customers get into an agreement with ARTC to actually ship their goods, and ARTC ships them, and the customer pays ARTC, right? And they pay for the weight or the tonnage. The actual term is tonnage, right? That gets transferred over the network. The customer pays ARTC for that, right? But for ARTC to realize this revenue, it was super manual. It takes, it probably would have taken months for them to realize this revenue from the customer, because they had to, correlate all the weights and aggregate and then do it as a manual process. Whereas when you automate this, when you make it real time, because there are web bridges which are IoT enabled anyway, and you can get this information in real time. When you can actually automate this simple process, revenue can be realized faster. And who will say no to getting money faster, right? We always say yes. So that was another key reason to actually choose that as well. And one of the reason as well is, I probably give you an analogy. Imagine if I was the web bridge capture team at ARTC, right? And I'll give you an analogy now. If I wanted a coffee, I could have probably gone and bought a coffee myself. But imagine if I went to my wife and I was like, hey, can you please make a coffee for me? The wife comes back and she's like, yes, can you please go to the grocery store and get milk and beans? And then I'm like, all right, sure, I'll go get it for you. And then she comes back again, she says, all right, you're already going to the grocery store, why can't you get some veggies and fruits as well? Because it'll help us go for the next week or so, right? So that's exactly what happened with web bridge capture as well, right? From a business context, if I have to kind of give you the other side of the story now, it's all about weights, right, and customers. But for us to do this, you have to ingest network information from the entire network that ARTC manages, right? And it talks about, network efficiency comes into picture, maintenance efficiency comes into picture, safety comes into picture, because only if your network is efficient enough, only if your maintenance is top-notch, only if you have a safe network to run your rails, you'll be able to run more trains in the network. The more trains in the network equals to more tonnage equals to more revenue, right? So this was an underlying reason as well for this, because it touches all the required source systems, most of the major source systems that ARTC has as well, right? So let me walk you through briefly as to the data and what were the data sources that were actually used for this, right? First one is called ANCO, which is ARTC's Network Control Optimization Unit. What this gives us is this system gives us real-time train journey information. And it also gives the journey plan for the next 30 minutes. So you can actually visualize the journey plans in a screen. It'll tell you, all right, this train, it has about 100, 200 carriages or whatever. It's actually traveling at this speed, and it's actually here. And then the next train is 30 minutes behind or 40 minutes behind. It'll give you the journey plan. And the distance between the trains in the same network is called a headway, right? So any train operator or a network operator like ARTC, the key metric that they would be interested in is to reduce the headway, right? When you can reduce the headway, you can run more trains in that given point in time, given duration, which equals to more tonnage anyway, right? So Anchor gives us the information about headway and the journey plans. The next one is called ICE. It's called an in-cab communication equipment. So there was a massive national train communication system network that was built in Australia to actually back this up. And every train has an in-cab communication equipment, which gives us real-time GPS information, real-time location information of the train. And it also gives us other information, such as temporary speed restrictions, right? So speed restrictions could be forced speed restrictions, where we say that, okay, this train has to travel at this speed at this point in time. Or it could be other restrictions because of failures, speed breaks, or because of any weather incidents as well. So ICE is a system that gives us this information. The next one is ICW, which is called Instrumented Coal Wagons. And this is a conditioning monitoring system that actually gives us real-time information about the network condition, right? It kind of detects vibrations, and it detects, any kind of malformations in the network, and it'll give us that information in real time. This is another real-time source. And we then have weighbridges. So this entire use case is about weighbridges, right? So weighbridges are trade-certified weighbridges, technically. That's what it's called. But it has been installed at various points across the network, which actually capture weights as the train passes by. And it captures weights. It's not like a weighing scale where you just go stand and shows one weight. It captures weights at a pretty granular level, as we're depending on the train and depending on the number of carriages that the train has as well. It's a sophisticated weighing scale, right? And then we have coal train path, which is a static source system, which gives us information about the rail haulage providers, who are nothing but the train operators, right? They give you, kind of the wagons and the engines to operate. And then it also gives us information about the coal producers who actually ship their goods in those trains. So from an ARTC perspective, both these are ARTC's customers, right? So this is their customer master information, right? And then finally, we have historical data as well, historical Anchor data, about the journey plans that we had for the last 10 years, which were used for pattern identification and correlation analysis. So these were the key data sources that were required for us to build a weighbridge MVP. And now you can understand as to why this was chosen again, right? Because you have network information, you have train information, you have customer information, everything required for us to build the foundation. So when we build the foundation based out of this, the other use cases for ARTC becomes easier in the future. And then data is one part of it. And as we all spoke about, integration was the other key part of this as well, right? Because ARTC's source systems are all event-driven. So communication between one and another should be in real time based on conditions. So integration played a key role as well, right? So on top of an enterprise integration framework, a REST API-based serving layer was also chosen because external serving of data was also one of the key requirements as well, right? So because customers access the data for various reasons. Now, moving on to the architecture. So there were key requirements to actually land on an architecture. And what are those key capabilities that were required? The first one is to process batch and stream data, because most of the sources are streaming, but there are also static batch sources as well across ARTC. So they needed a platform that is capable of processing both. And then the capacity to aggregate data across various metrics at various point in time, right, in real time, right? So capability to aggregate streaming data in real time is also another key requirement. And then cost-optimized storage was also super crucial because of the history that actually gets retained And because it's sensor-heavy data, there's a lot of data that gets stored. So storage, which is cost optimized, was also crucial to consider as well. And then finally, capability to integrate with existing enterprise integration systems and application serving layers, was also another key capability. So Databricks kind of checked all these boxes, right? And actually, plugged in really well in ARTC's ecosystem. So if you have to move from left to right, I think I've spoken about all the data sources already. So the streaming data sources were ingested using Event Hub, and Spark structured streaming was actually used to pull all these streams, separate streams, like the GPS stream. It could be an ICE stream. It could be an ICW stream. All these streams were pulled using structured streaming onto Delta, and the medallion, bronze, silver, gold layers were built, and it was all built in real time, right? And the batch sources, like you can see the cold train path and the historical data, and there are more batch sources as well. They were all pulled using Data Factory, and they were also populated in the same medallion, bronze, silver, gold layers as well, backed by Delta. And finally, aggregates were created. So there were streaming aggregates created by the streaming pipelines, and there were also batch aggregates created for reporting as well. The key metrics that were aggregated by the streaming pipelines actually fed the enterprise service bus. As I said, it's an event-driven architecture, right? So if I have to give you an example, let's say if the ICW system, which is the condition monitoring system, detects kind of any vibrations or detects any malformation in the network, it sends an event in real time. And if that event is picked in and it's correlated with the location as part of your stream, that should then alert the ICE system to have a temporary speed restriction for the next train that's coming on the same network to say, hey, something's wrong in the track. Please reduce your speed to 50 kilometers per hour or 40 kilometers per hour. That has to trigger that. And that trigger will then have to modify the schedule in Anchor to say, all right, because the next train is going to slow down, let's create more headway between the other trains in the network, so the schedule is altered as well. And all this sequence of events that actually has to happen in real time. So integration plays a key role, and an event-driven integration plays an even more key role here, right? And so the batch aggregates for reporting were also built, were available in the gold layer, and the analysts used that out of Databricks via Databricks SQL warehouses onto the reporting tool in Power BI as well. And one such example is they run as a Power BI report is a weighbridge calibration report. So this report is a frequently refreshed report based out of the weights that get pulled out of the weighbridges, along with location information and other informations as well. And what does this give is, what does this report give to the ARTC users is any calibration mismatches across weighbridges, right? They will be able to pick that up, fairly quickly. And what then that leads to is scheduling work orders to go and do recalibrations if the weighbridges are not calibrated properly. So these are some examples of reports that they run in Power BI, which feeds out the Lakehouse. So as you can see, this architecture, backed by Databricks, supported their streaming event-driven use cases, also supported their reporting use cases as well, right?
Just like to add two quick things there.
Sure.
So that Cosmos DB that you are seeing there is then finally became that enterprise event directory, and it can provide that in the distributed way. And second important thing is, this is a classic example of making sure that you work on the weighbridges. You optimize your processes while the operations is happening, such as when the train passes those weighbridges and we get to know the calibration issues, rather than running a dedicated train to then figuring out the issues. So it's about, we moved the maintenance job within the regular operations of the ARTC itself. Yep, over to you.
Awesome, thanks, Harsh. And that architecture had a lot of benefits, like the regular Lakehouse benefits of consolidating data, consolidating governance, unifying streaming and batch. There were a lot of benefits, right? But I'm not going to touch upon all that. I'll highlight the key feature highlights, right, that helped us deliver such an event-driven architecture at ARTC. One thing was the custom stateful processing that is supported by Spark structured streaming. As we saw, most of the sources are streaming sources, and there were requirements to aggregate data based on different conditions and maintain states at different levels, right? And aggregation had to be done for customers. It also had to be done for different data points in the network as well. So structured streaming has stateful processing with the capability to handle late arrival data, right? So you'll be able to do that as well, and also maintain state, via an external state store. So even if you have like 1 million keys to aggregate state on, Spark structured streaming has the capability to do that. It supports a RocksDB state store, so you don't have to maintain all the state in memory as well. That was super powerful. The next one is aggregation watermarking. As we saw, right, we merged the GPS stream with the condition monitoring stream to identify where a specific condition has occurred on the network based on the GPS location, which is technically joining two streams together, right? And streaming, solutions are always complicated because you can't always rely on event time coming, right on time. There'll be some delay because of latency issues or because of any other network issues as well. So we have to be super sensitive of not just dropping the data, but we should be able to handle late arrival data as well. Again, Spark streaming, watermarking capability helps you, within a specified threshold, handle late arrival data and not miss it as well. And the last is auto optimization. Again, because we were streaming heavy, there were a lot of small files that were generated, and small files are always a problem for performance as well when you try to query them. So Delta and Spark, supported auto optimization and auto compaction. So it'll automatically compact your small files, in the disk, and it also optimizes your files before writing it to the disk as well. So this was also another key capability that helped us build such a streaming-heavy, event-driven architecture successfully. So now that MVP was proven, we have like 3.5 minutes. I'll just take the next 1 minute, and then I'll open it up for questions. So now that MVP was proven, ARTC took this to the next step, right? To say, all right, our next big strategy that we want to work towards is pathway to zero. This is technically ARTC wanting to have 0 incidents in the future at some point in time, which is technically a safety network, right? It's a highly safe network. So for that, what ARTC did is, on the same Lakehouse, they embraced on advanced analytics now. So they had most of the data required for this already as part of the MVP. On top of this, they brought data from Works, which is another system that actually gives maintenance inspection data, along with weather data, married that up with the existing ICW data and other data in the Lakehouse, and they built a rail break prediction model. And what are rail breaks? As we heard from Harsh, everything is about tonnage, right? The more tons you deliver across the network, the more money ARTC gets paid. The key reason for that not to happen is reliability issues, reliability losses, that's what they call it, right? And the key reason for reliability losses is rail breaks. The number one key reason for reliability losses is rail breaks, followed by signaling failures and other failures, right? And rail breaks happen because of weld issues, because of insulated joint issues. It happens mostly in winter. There are reasons for that, right? And just, if you want to take a guess, imagine, and I'll probably ask a question, just guess, if you improve reliability by 1% for the scale of ARTC, any guesses as to how many more tons we can we can carry in the network? More? Just a 1% increase. Any guesses? How many more tons can you actually carry? 1 million? Million? That's a good guess. Anyone? 1% increase of reliability equals to 40 more million tons that can be transported across the network, which is a lot of money, right? So this rail break model was entirely designed to actually predict rail breaks well ahead of time and to make sure work orders and maintenance has been scheduled way ahead of time to actually avoid those. Right. So real quickly, so what was ARTC able to achieve out of this? 30% increase in freight logistics optimization, which means 30% more tonnage, TLDR, and also an 80% reduction in data engineering hours because of the frameworks, the reusable templates that we built as part of the MVP. Everything else became easier, right? And that actually saved a lot of existing infrastructure costs with all the siloed SQL estates, and also saved on a lot of OpEx costs as well. And this is one of the things that I wanted to show you as pathway to zero. It's not just about tonnage and revenue, right? It's also about human lives. It's also about safety, right? And ARTC was always on the right track to actually achieve this, and they had to reach the last mile, and Databricks is actually helping them cross the last mile, in achieving the pathway to zero targets as well. They're very close there, as you can see. So we've seen the what and how, and now what we'd like to quickly cover is what does the future look like for ARTC, right? Now that we've built Lakehouse that actually backs this modern design, right? It opens up an API economy for ARTC in the future, becoming, ARTC being the heart of supply chain, they can actually bring in multiple other parties, to the game, and then create an API economy, right? So do you want to quickly cover that for 30 seconds, and then we can
Yeah, just probably one sentence I will say is, by doing all of this, we are now managed to self-fund our transformation, which is a very rare incident in the business. And because of that, you can see within 3 years itself, we have managed to achieve what we have achieved. Thank you. That's it from me.
Awesome.
Yeah.
Cool. Thank you.
Thank you, guys.